Self-driving cars are navigating this secret, invisible world made entirely of data. But what happens when that world gets hit with a massive traffic jam? Today, we're going to pull back the curtain on the digital highways inside these cars and a really critical flaw that could bring everything to a grinding halt. Okay, picture this. A fully autonomous car cruising along, when suddenly it's hit by dense fog, or maybe a crazy snowstorm. Its cameras and its LiDAR, its eyes on the world, they're suddenly useless. So what does it do? How does it possibly stay on the road safely when it's basically driving blind? Well, it turns to its secret weapon. And listen, forget the GPS on your phone. This is a whole different beast. We're talking about a digital twin of the road, a blueprint so incredibly precise it can guide the car even when its physical sensors can't see a single thing. But, and this is a huge but, for this digital guide to be reliable, it needs a constant, non-stop stream of real-time updates. So how do those updates get there? They're delivered over this special network called a VANET, a Vehicular Ad-hoc Network. The easiest way to think of it is like a private, super fast social network just for cars. It lets them constantly talk to each other and to servers about what's happening on the road. And it's right here, inside this digital conversation, that our story really kicks off. So let's talk about just how vital these maps really are. I mean, it's easy to think of them as just a simple backup plan, right? But the truth is, they are an absolutely core component of how these vehicles see and safely navigate the world. This HD map gives the car centimeter-level detail about everything. Lane markings, curbs, road signs, you name it. It's what lets a car plan its route and make those split-second, life-saving maneuvers. But here's the catch. A map is only as good as its very last update. If a construction crew shows up or there's a sudden accident, an outdated map is actually worse than no map at all. It's dangerously misleading. And that right there, that absolute need for fresh, up-to-the-second data, well, that brings us to the heart of the problem. The very system that's supposed to deliver these critical updates has a major flaw, one that creates a really high-stakes digital traffic jam. This visualizes it perfectly. Just like a car waiting to merge onto a packed highway, a little packet of data has to wait for an opening on the wireless network before it can get sent. So the more cars that are all trying to send data at the same time, the longer that wait becomes. You get the picture. Now, the current system is called IEEE 802P, tries to manage all this by sorting data into 4 priority lanes. You got voice and video calls, they get the express lanes, no problem. Basic file downloads, they're sent to the slow lane. But take a close look. Our critical, life-saving HD map data is just lumped into the best effort category. It's stuck in the exact same digital gridlock as someone just casually browsing the web. And hey, don't just take my word for it. The researchers who dug into this problem put it perfectly. This system, as it's built right now, simply doesn't recognize how important this HD map data is. It's a critical safety feature that's being treated like it's totally non-urgent. So how in the world do you fix a digital traffic jam that's baked into the system? You can't just add more lanes to the highway. Or can you? As it turns out, the researchers proposed building a brand new one, a dedicated digital express lane. What they came up with was a really clever software fix. They created a totally new 5th category, which they named AIFS. You can see in this chart, it's basically a dedicated high-priority express lane built for one thing and one thing only, HD map data. The logic behind it is pretty simple, but it's really powerful. First, the system identifies any incoming HD map data. Then, instead of just tossing it into that slow, best-effort lane, it routes it straight to the new A-Link HD express lane. This new lane is set up to have a much higher priority, which lets it merge into the data stream way, way faster. It just gets to bypass all that digital congestion. Okay, so it's a really elegant solution on paper, but does it actually work in the chaos of a crowded digital street? Well, the researchers ran some pretty detailed simulations to find out, and the results, they weren't just good, they were absolutely transformative. The big headline number? A whopping 80% reduction in the average delay for HD map traffic. Now that is not a small improvement, that is a complete game changer. Let me break that down for you. In a really dense situation with 50 cars all talking at once, the standard system had update delays of up to 200 seconds. That's over 3 minutes. That is an eternity for a car that needs that data right now. With this new express lane, that delay just plummeted to only 2.3 seconds. Incredible. And it wasn't just about speed. The solution also boosted something called throughput. That's the total amount of data that actually makes it through the network successfully. And it boosted it by a massive 80%. So not only is the critical data arriving faster, but more of it is getting through without any errors. And look, these results weren't from some perfect, sterile lab. They came from a realistic simulation of a 100 by 100 meters city block, jam-packed with up to 50 autonomous cars all trying to communicate at the same time. This was a digital stress test, and it was designed to mimic the absolute chaos of a real city street. An 80% improvement is a massive leap forward, there's no doubt about it. But what does it really mean for the future? Is it enough to pave the way for fully autonomous driving? The researchers also started wondering, what happens if you pair this smart software fix with even better hardware? So they tested their solution on a newer, faster wireless standard. And while the express lane is a huge boost for the current system, pairing it with that newer hardware, well, that gets the performance even closer to the industry's ultimate goal for truly real-time updates. And this right here brings us to the final, crucial piece of the puzzle. An improvement from over 3 minutes down to just 2.3 seconds is, frankly, incredible. But the group that sets the standards for this stuff has a target for real-time map updates of just 100 milliseconds. That's a tenth of a second. So as great as this is, we're not there yet. The solution is a huge step, but it shows there's still a pretty big gap to close before we hit truly instantaneous updates. Which leaves us with one final thought. We are building cars that can think for themselves, but all of their intelligence depends completely on these invisible networks to share what they know. This research is fantastic. It shows we can unclog those networks, but it also reveals just how much more traffic they're going to need to handle in the very near future. So the big question is, are our digital highways really ready for the traffic of tomorrow?